Hello, welcome to Java in 1 hour. In this course, we will cover the basics of Java programming within 1 hour. By the end of this course, you will have the foundational understanding of Java and you will be able to write simple Java programs. So without further ado, let's begin. But before we do that, my name is Dr. Zeeshan Bhatti. This is my channel. I will be posting many of the video lectures on coding and programming, so don't forget to subscribe. Now let's get started. To start programming in Java, you need to install Java Development Kit. To do that, let's head on to our browser. So first thing you need to do is go to your browser. First thing is you go and search on Oracle, or you can just simply say JDK download. Okay, just Google it out. It will take you to the Oracle's website. Go on to the Java download and find out this most latest version suitable for your systems. In my case, I'm using Mac. I will be downloading the Mac's DMG installer, download and install it. Easy peasy, nothing to worry about. If you're using Windows, again, you can go for Windows installer or an archive file that you need to unzip, install it, easy peasy installation, nothing to do. Okay, once you have that, then you need to go into VS Code. So you can go on to google.com again and you ask the brother Google that, hey, VS Code download. It will take you to the VS Code website where you can download the VS Code. For Java, you don't exactly need VS Code, but again, this is one cool web programming editor that's been used across multiple platforms. Again, for me, I'm going to use Mac. You can use Windows or whatever you want. Once you have downloaded it, go to the extensions and type in Java. Okay. It will load up certain extensions that you would be or recommended to use with Java. So for example, one is Java's extension pack. So make sure you download this pack and then install it. I've already done that. Also, I use a debugger for Java and the test runner for Java. This allows us to have more control over the Java and easily code it. Then one other code extension we need is called Code Runner. So if you type in Code Runner, come here, make sure you install that as well. Since I've already done that, it's already there. So you need this couple of extensions, just restart VS Code and you should be good to go. Once that is done, let's just come back to our Java's code and start working with Java. Now, the basic Java syntax is this. So every Java code must start with something called a class and then class name. So for example, this can be my class name, bracket start, bracket close. Now, this is a typical class. Every Java code needs to have this, what we call class name. This class name can be, for example, student. This can be teacher, this can be whatever code you want to basically work with. Okay, so this class basically serves a particular purpose. All the code within Java goes inside this class. Then you need to write something called public, static, void, and main. Okay, and then make sure void is also void void. Oops, spelling absolutely important in Java. Then make sure you do that. Then we use string arguments as an code like that, block start, block close. Now let me explain what I've done here. Now inside Java, we write something called public and make sure S is also small. Public basically means that this is a public method that can be accessed anywhere within your system. In other words, let me explain in the reverse order. What this function does is that whenever you execute a code, Java's compiler needs to understand where to start your execution flow. Okay, so if your code has millions of lines, which is the starting point? So by default, JVM, Java Virtual Machine, will execute this main method inside this student class. So because it needs to access this main method, it has been declared as public, so it can be accessed outside via JVM, which is actually separate software I will talk about in a moment. Static means that in order to access this method, you don't need to create object of this class. What exactly we mean by object? I'm going to talk in objects, but meaning that because this method is inside a class, you cannot directly access it unless you create an object of this class, means an instance of this class. But because this is going to be used by JVM, we have set this as a static. Static is a keyword in Java that will ensure that our code is run directly without creating the object, just by using the class name. Void here specifies the return type, meaning that when this method executes, it's not going to return anything. A string argument, and this is a symbol of array, means that when you execute, you can give it certain values to process and work with. So it's like handing some money to somebody that go and buy this thing. So when you pass some value to somebody like a money that do this thing, meaning we are passing arguments. So this is a default function. Every Java code needs to have this. Class name, block start, block close. These blocks are absolutely important in programming. They mark the block of code, as we refer it to, means the code starts from here and ends here. Then inside this code, we write public static void main. This is the starting function. Every JVM will use this as a default functions. Now this becomes our typical. How do we generate output? So we use something called system.out.println, and then we're going to use semicolon here, inverted quotations. I will explain in a moment, and hello world. Now, whenever we write a code, we need to print something on our screens. To do that, we're going to use this system.out.println. So print is actually a method that will print the output on a console on this terminal here. Because this is a public method, we don't want to create an object of it. It has been specified as static in its definitions. But this method is actually inside a class known as system. Just like our student class, there's a class inside Java's API. It's in our library called system. Inside that class, there's a subclass called out. Inside that out, print method has been declared. The syntax is that we use these round brackets, just like we have used it inside here. Every method in Java needs to have this round method. This print method needs to print some string or something which needs to be in inverted quotation marks. So once you write it and execute it, you will get hello world output on the console. Okay, that's because this is what we are trying to do. We are trying to create our class that needs to work with it. Now, once you write a class, press Ctrl S and you need to save it. Make sure you save it with the same name as your class name. So my class name is student with capital S. So I'm going to use the same name, student.java is the extension. Every Java source code must be saved in a Java file. That's how we do it. We click on save. It's going to say replace. No, I already have it. So let me just make this as student, for example, to student teacher, for example. I can rename it class save, and then I'm going to rename this class as well, student teacher. Okay, so this now becomes a student teacher class, and now I can easily run it. So now if I come back here and run the code again, you would find that I get a hello world code because now it's saved. So when we save this as a class name, our Java will know this is what's happening. Public static void main is the default method. This is where our code's execution starts. Then you can have millions of lines of code, but by default, JVM will execute it. Now, what happens when we execute our code? Okay, every time when we execute our code, we can say Java execution flow. Okay, what happens is that now, first thing, note that I'm writing comments. Comments are basically one way of telling our Java's compiler that just ignore it. Okay, whatever you use within this double backslash will be completely ignored. Or you can use something called backslash static. Oops, not here, not here. My keyboard is going haywire. Backslash static and then static backslash. These are known as multi-line comments. This basically means that, not this one, static backslash and backslash static. Okay, what this basically means that you can write multiple lines of comments. Now, this is how our execution happens. We write our code, okay, then we say we compile our code, okay, CUMP, I really compile code. I'm forgetting all the spellings. So compile the code. When we compile the code, basically is JDK compiler reads the code, okay, checks errors, and then what it does is it does something very fantastic, which is known as 3 compiler generates a byte code file with same name as class name. Okay, so when I write the code, my code is running. As soon as I hit compile button here, the compiler is basically a JDK. It's like a software that compiles the Java's code. It checks the code with errors, any issues, any problems if exist. It's going to give us the complaint. If no errors occur, okay, it's going to compiler will generate the bytecode. Bytecode is basically a file that exists which contains a machine readable code. Okay, that machine readable code is then uh, bytecode file is then executed by something called JVM, which is Java Virtual Machine. Okay, so JVM as we call it. So JVM is basically responsible for executing our bytecode file. JVM needs a bytecode file that has no errors, and Java's JDK compiler reads the file code and generates that bytecode file. Every time we compile our Java code, you would find that there is a extra file known as the bytecode file saved with same name as the class name. So this is typically how Java works, and this is how we generate the output on our console. This is what we refer to as comments. Okay, now let's talk more about Java's variables. What exactly are variables? Now, variables are data types. So for example, if I declare integer var is equals to 10, this is a variable of type integer. This integer defines that I have a number form of variable. In Java, there are various different types. We have character variable, okay, char, character, which is, for example, a single character like a, and then it ends with a semicolon. With respect to byte integer, we also have something called byte, okay, bt, and we can say, for example, 2. We have something called short short as well, and we can say st is equals to, we can give it any value, semicolon. And then we have character. We also have something called boolean, okay, and then we can say bool is equals to, it takes either true or false value, so on and so forth. Okay, then we have something called a float value. So ft is equals to, for example, 34.5, which is basically a decimal value, and we use f with it. Then we have something called double. These are what we known as data types, is equals to 34.45 or whatever we use it here. Now these are known as data types in Java. Okay, data types in Java. Integer is basically typically a number form, so we can say it's a number which can be any positive or negative number. That's it. Okay, byte is again a number, but it occupies 1 byte in memory. Okay, one by an numb number and occupies 1 byte. Integer is again a byte, but it occupies 4 byte in memory. And short is again another number that occupies 2 bytes in memory. Now what happens is that every time we want to save a value, for example 10, computers needs to understand what type of data this is. Okay, this 10 is a number, so that's why we use something called integer, byte, or short. We can use any three of these. However, these three differentiate with respect to memory size. Because of the way computer works is that when you create a variable, it needs to store the data in a memory, and then how much space should be allocated to each data, that is basically dependent on what type of variable you have created. If you have created integer variable, in memory it will occupy 4 bytes. Based on that, the space is allocated. If you create a byte variable, it will occupy 1 byte in memory. If you create a short variable, it creates a 2 byte in memory. So the memory allocation is based on that. These are all numbers. Similarly, character is there, ch, it's just holds one single character at a time. Okay, boolean is a data type. It holds either true or false. Okay, or sometimes we also say true is basically like a 0, or sorry, like a 1, and false is just like something called 0. Okay, so it can have true or 1 or basically false, so it holds only one value. Float and double again are our data types that hold decimal values. Whenever you want to use a decimal value, basically you need this float or double. So decimal values is there, and then again this occupies 4 bytes, and then if you occupy something called decimal, and it occupies 8 bytes. Okay, along with short we have something called long as well. Okay, lg, again variable name can be any. I will talk about this. This is basically a very long variable, so you can declare a very long variable with that if you use what we call l with it. Okay, and this is again a number that occupies 8 bytes in memory. Now why we have used l here and why you have f here, because this is a floating value, and it's needs to identify that this is a floating decimal value of float type. For double, you don't need to specify that. In other words, this is a default. For long, again, you need to specify l, telling it that it's a long variable. It occupies 8 bytes because now it has more memory. A very huge number can be resided within. The way this data type works is that we have a value, we assign the value to a variable, and we need to tell in the system, the memory, the Java's compiler, that what type of data it is. These are known as data types. We use this to store value. Each data type is able to hold one single value at the same time. Okay. At the same time, you can have something called multiple variables. Okay, which basically mean you can declare integer x, okay, x is equals to 5, for example, y is equals to 6, for example, and z is equals to 9, for example, and then semicolon. What this basically does is that you can use integer data type but declare multiple variables on the same line. So rather than integer, you can use integer x is equals to 5, comma separated, y is equals to 6, comma separated, z is equals to 9, meaning that now you have declared three variables on a same line. You can use same thing as well. So integer, for example, x, okay, or you can declare integer y comma z, okay, and then you can say x is equals to, for example, 98, and then you can say, hang on, y is equals to z is equals to 67, for example, or 76, for example. Okay, now what these basically mean, they are basically defined that I have a variable called integer x. This is what typically we call a variable, oops, declaration. Okay, if I use the comment sign again, so see, I'm using comments. These comments are basically ignored by our compiler. So I declared a variable called integer x. Okay, now this is giving me an error. Why this is giving me an error? Because I've already declared a variable called x. That's why we use VS Code. That give you these red lines indicating that there's an error in this code. So it says, hey, there's a duplicate value. So if you hover your cursor, it will tell you duplicate local variable. So if I change it to, for example, double x, now it becomes okay. If I use y again, because we have declared y, in Java, you cannot declare two variables with the same name. So you're going to say, let's just move this to, for example, double y, or for example, z3. That's all. But make sure there's no space. If you use space between them, now these become two different words and Java will complain. So the variable names cannot be, it cannot have a space. Also, you cannot begin a variable name with a number. Okay, variable name must begin with an alphabet, small or capital, up to you, but they must begin with a alphabet. If you use number, again it will complain an error. If you use special characters like and or steric or brackets, it's going to create lots and tons of errors. You can use underscore though, that's allowed. You can use underscore 3, that's also perfect, no problem with that. So since I've changed this, I can use double x. Now this is basically what we call variable initialization. Variable initialization means we have initialized a variable. So here we declared a variable, here we have declared multiple variables on the same line, here we have initialized a variable, same we have initialized multiple variables. Now what is difference between these and these two is that we have said that 76 is assigned to z, at the same time this value is also assigned to y. So these two variables will now have exactly same values. Capish? Excellent. Now, what if we want to print these values? What we do is we come down here. We're going to say again system dot out dot println, and I'm going to just use variable called double x. Okay, and if I hit run now, if everything is okay, you will find that we have an output called hello world and 98. 98 is value of this one. So you can print the variable's value. So now what happens is that this variable behaves like a container. The data is saved inside these variables, and now you're using it. Okay, similarly you can use a string with it as well. So you can have as many system.out for that matter. So we use another system.out.println, and I'm going to say for example the value of y is, and then I'm going to use plus y. Now what happened here is that I've used a string and then use a plus operator. Now typically plus is a mathematics, okay, it's a mathematical operator, but here what it is doing is it is concatenating the value of this string plus this value of y, which is 76. So it's going to print what, oops, the value is giving us the error, the value is giving us this error. Okay, because we have not saved the code. So make sure you save the code before you execute it. So once we are here, recompile it. After saving it, the value of y is 76. Okay, every time you change the code, do remember you save it. Okay, because the compiler needs the whole file, but to read the file it needs to be saved, otherwise it will just go to the last previous saved state. So once it's there, it's there. So now we have while. What is it again doing? The value of y is concatenated with this string value. Understandable? Excellent. Let's move on to further topics, which are basically these plus operators. What, how, and these operators work. Okay. So we have seen that we have other operators, like for example, if I say operators operators, we have for example y plus z, okay, x, or let's, if I type x, so this becomes one simple calculation. We can do that, but see, there's an error. Why there's an error? Because it says that you are performing a mathematical function y plus x. I would calculate the value of whatever is saved inside this y variable with the value of this x variable that has been saved here, but where should I give you the answer? I need to receive that answer as well. So to get the output, we can write system.out.println, and then we can say, okay bros, let's just come back here and then brackets. So now what we have done here, inside the system.out.println, we have performed a mathematical calculation. So save this code, Control S, run this code. Now we get 81. Okay, because the value of 76 is added to the value of x, which is 581. Now you can ask that when we did the plus here, it added these two strings together, these two values together, like a concatenation joining. But here it's performing mathematics because there are both integer numbers. Both are integer numbers. Because there are two numbers, this is gonna add it. If I add a string to it, adding numbers, okay, and then I add a plus here. Now what's going to happen? Control S. If I run this code, see it's printing 76.5. Okay, adding the number here. What's happening here is that it's going to take this string first and add with this thing. But because this is a string, string cannot be mathematically added. So these two numbers are concatenated. So initially the value of y, which is 76, is concatenated with this string. Then it's going to take the value of x. It says, hey, because this has been converted into a string, now I'm going to add the value of x as a string. So it's just going to append it. The mathematical functions are not now performed. In other words, first mathematic rule is we perform this function, then this function. Because the string has been added, this whole answer now behaves like a string. And then that string is basically added to this. You say, what is a string? A string, again, if I go back inside my data types, string is again a data type. So we have something called a string, string, string. St is equals to, and I can say, for example, this thing. So whenever we want to use, okay, st variable has already been used. Yes, short variable. So again, you cannot use same name on two different variables. Java is going to complain. It needs unique names every time. So for example, I say name here. Makes more sense, right? So we define the variable names for their purpose. Now we're going to say, listen, this is a string. Assign this string to this container, this variable called name, and make sure its data type in memory is of type string. So when we use this, again, Java needs to understand in memory what type of data this entire expression is. So it's going to take this first string. How does it know it's a string? Because it's inverted quotation marks. It's going to add these two things together. So this behaves like a string variable to us. So this is what we say a string is. A string is just simply a combination of multiple characters. Okay. So now moving forward, let's talk about the math class. Okay. Now Java has many built-in library classes, or what we typically refer to them as APIs. What these APIs allows us to do is it allows us to access certain libraries that have pre-built functions and we can use them. And you would be coming across these built-in APIs consistently, and that's what makes Java so powerful. Because of the large community, there are a huge number of APIs. So one common example we use is the math class. So for example, we use math class. Again, there are many other classes. This is just to show you what a math class is. That it's a built-in class called math. It's built in there. By default, it has been imported in our every Java code, so you don't need to worry about how to include it. And then you can use various different functions for it. For example, there's a function called max. Okay, what this does is it tries to find out what is the maximum value in your code, or amongst these two arguments. So we provided two arguments. Argument A is 5 and argument B is 10. Max is a function or method inside Java built in, okay, inside this math class. So this class is already default present here. Now what this does is that it allows us to find out that I have two values, which one of the values is bigger and smaller, based on, for example, it can be user input based on some data that we are processing, and we want to know, hey, which file size is bigger, which data is bigger, which value has a higher number of views, and so on and so forth. So we pass it two values and we can very easily determine that amongst these two, which are bigger. Now in this case, we need to receive a number as well, because this method also gives us the maximum value. So we can say integer max is equals to math.random. And then if you go and print this out, you can say system.out.println, and then you can use this max value. Again, if you want to attach string to it, you can do that. Max value is, and then because we have attached a string with a variable, we need to use this plus operator. So this string can be concatenated with whatever is the value inside this variable. Now, this is again one example of max. So whatever, when we run this code, we will get this value 10, because it will tell us that, hey, this 10 is bigger. Similarly, there are many other functions that you can use with this thing. For example, we have math.random, okay, math.random. What this function does, it automatically generates a random value for us. So if you use this inside the system.out.println, you can generate a random value, or you can use, for example, a double, and then you can say ra is equals to math.random. So it will generate a random number between 0 and 1 and assign it to here. And also, as I said, you can use this inside system.out.println. So you can say system.out.println, and then instead of using this, we use math.random, and then we close the bracket here. Always remember, semicolon comes at the end of the statement, so it must be end of the statement. So if you're using a print method, that means you start a bracket, you close the bracket, and whatever you write inside it again goes inside it. So in this case we have, in this case, what we have a value or another method that is running inside system.out.println. Now math, being a built-in class, has around 70-80 different mathematical functions, like sine, cosine you can use in this case. So if you run this code, control S, again don't forget to save this code. If you execute it, now you see that we have adding numbers, and at this last point we have a random number between 0 and 1 in terms of points you can generate, and then you can again multiply with 1 and 10 and generate various different sequence of this math.random. You can try to explore in later examples. Or the maximum value amongst this is 10. Okay, so this becomes math class. There are hundreds of functions that you can use, like sine, cosine, square root, logarithm, finding tangent values. All are inside this math class, and you can use it. To refer to the code, go to the W3Schools website. There's a complete list of methods that you can use, or you can explore Java's documentation to find out the entire list of how to use that. Okay, then moving on forward, now we have something called Java Booleans. Okay, Java Booleans is basically Java Boolean data type. So we have used Boolean in the previous example also. So Boolean, for example, bool1 is equals to true. What this basically means that this is a variable that only stores either true or false. So I can say Boolean, okay, come here Boolean, and I can say bool2 is equals to false, semicolon. So every statement ending with semicolon, that's an important, I forgot to mention it previously. Now what happens, this is only two values that we can save inside the Boolean data type, but it's a quite important data type, because in further we will be using something called relational operators, and they return a data value in form of Boolean, and then that is needed to be saved inside the memory. So it needs to know that the data that we are getting is either true or data we are getting false. So this Boolean occupies 1 bit in memory. Okay, so it only, as we say, 1 bit in memory, 1 bit meaning either 0 or 1, that's all it goes. So true technically is saved as 1 in memory, and false is saved as 0, but Java directly reads to these words as well. Now true and false are Java's reserve word keyword, meaning that I cannot use this as a variable name. This will give me an error, because false is Java's reserve word, true is Java's reserve word. Same as integer, byte, float, character, short, long, all these are Java's reserve words. Java knows about them, and you cannot use them with your variable name, class name, or method name. Okay, so that's why we give it different names from what the values are. So this becomes our Boolean data type, and we'll explore this Boolean data type later on in relational operators. Okay, so now let's talk about these relational operators in a moment. So we have something called arithmetic operators. Okay, arithmetic operators, as you know, are plus, minus, multiply, divide, and remainder operator. All these are known as arithmetic operators, obviously meaning that you can perform any sort of mathematical operations in your system. So for example, if I use system.out.println to print the output, I can say oops, why do we get double quotations? The answer is, again, because I'm using a string, plus, and I can say, hey, let me go inside 5 multiply by 10. So basically it will multiply 5 and 10 and print the value here. Okay, at the same time, if I use, again, let's just be a little bit lazy and copy this entire expression, come here, control V. If I come here, this can be multiplication, but what if I do adding now, ADDING, adding, and I can say 5 plus 5 multiply by 10. What will be the answer now? Okay, do keep this thing in mind. At the same time, let me paste this one more time, and then I can say adding again, but this time instead of multiply, I use plus. Okay, and then I can say same expression, 5 plus 5 plus 5. What will happen now? What is going to be the output now? Okay, so first thing is we use this string, and because we are touching an expression, we again use plus and then 5 multiplied by 10. What will be the answer here? 5 plus 5 multiplied by 10, what's going to answer be here? But if you use 5, 5, 5, 5, what's going to be answer here? It's like a quiz. So if I control S, save this code, make sure you always do that. That's a common thing. Sometimes when we work with Java, we don't save the code, we assume it's there. I believe there's an extension you can install that automatically saves the code, but I like to press the control S every single time by myself. So once you do that, if you come here, if you compile the code and then you come at down, and then if you read the code, it says the multiplication is 50. So the multiplication is 50. Makes sense? 5 multiplied by 10, answer is 50. Perfect. However, when you come here, the adding is 5 multiplied by 5 multiplied by 5. The answer again is 550. How is that possible? Okay, how is that possible? Shouldn't it be 5 multiplied by 10, 50, then plus 5, 55? Answer should be technically 55. But I got 550. And then if you go at third line, the answer now is 5, 5, and 10. So why did I get 5, 5, and 10 printed as it is rather than actual arithmetic operation being performed? Now, this is something that I've talked about previously as well. What's happening here is that if you take the first expression, this is multiplying it. Multiplication has a higher precedence. Do always mean that. So in other words, what we call operator precedence in technical terms. So operator precedence. Okay, what this means is that your operator precedence will involve multiplication always executing first, then division, then we say we have something called plus, or in other words minus. Okay, so whenever you are using expression, if it involves multiplication, this will always be executed first, then divide, and then plus and minus. Okay, so in this case, because multiplication has been involved, it will execute first before plus. That's called operator precedence. In an expression, even in mathematics, this is what we do. We try to multiply first and then we add it. So this is exactly what is going to happen here. This is performing multiplication first. So 5 multiplied by 10, answer becomes 50. We get that in 50 here. However, in the second expression, again, we have plus 5 and this. So in this case, what's happening here is it's still doing 5 multiplied by 10 because this has a higher precedence. But once this expression has executed, the next expression will start from the left again, and the leftmost expression is solved. So after solving this expression, 5 multiplied by 10, 50, the value 50 as an integer is saved inside the memory. The next expression does not go in this reverse order, but actually it goes in the normal order. So this value is evaluated first, and this value is 5. And because the first part of the expression is a string, this will automatically add 5 in form of concatenation or append in form of string. So adding 5 plus the 5 is now added as a string. Hence, this entire expression becomes a string value. That is why after this string, the next plus again behaves like a string and adds these two values. Answer that was saved in memory as 50 has been added here. So even though the expression is here, remember if you are using this in system.out.println, plus 5 will always be added to this string. But because there's a multiplication, this has a higher precedence. This gets executed first. The answer is then appended as or concatenated or joined with the rest of the string. In third example, we see 5, 5, 5, 10. Because they all are plus, plus, plus. So the normal precedence go from the left. So this string is added to the 5, then added to the 5, then added to the 10. Hence, string 5, 5, 10 are all considered as a string operations. Okay, because the first result that we got from here was a string output. So it's going to solve this first expression. Whatever we got here becomes a string. Then that string is added to this value. Okay, then this value is added to this value. So all of these are a string added, string added, string added. Hence we get all these values here. Now at the same time, what happens if we reverse the order? So this is going to print, for example, 50 to us. This is going to print, for example, 5 and 50. Sorry, 550. However, this will print what we call what we call 5, 5, and 10. However, if I change the expression now, if I go back here and then I use this expression here and I can say 5 plus 5 plus 5 plus. Now what should happen? So now I've changed the expression here in this case. So again, space doesn't really matter at this point. You can give space, you cannot, up to you, but I usually prefer to give space, makes the code more readable and understandable. What happens if you use the plus 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 first? Always remember the expressions in general case programming, they are always solved from left to right unless there's a higher precedence. So because we want the expressions to solve left to right, so this will evaluate from left to right. So it's going to take 5 plus 5 plus 5. Up till this point, it will consider this as an integer numbers, and they will be solved as an arithmetic operation. So if you save it, go back here, execute it, see the number becomes 15. The answer is 15 because it considers from left to right 5 plus 5. Right? These both are integer numbers. Let me do mathematical addition. Then 5 plus 5, 10 plus 5, 15. Again, arithmetic operation. Then whatever is the answer of this is finally concatenated or joined with this string, and we get this string evaluations. However, if you do want to avoid it, okay, you can always put this. For example, if I have 5 plus 5 and then I want to say no, I want to do this entire mathematical expression and then do that. So we use the parentheses. So we add these additional parentheses now. Okay, what this means that parentheses again has the highest most precedence. So if you use something inside parentheses, anything that you write inside brackets will always get evaluated first. The end of story. So this expression, because now is inside the parenthesis, it will get evaluated first. Do keep in mind, sometimes the new programmers do confuse this, that hey, I probably cannot use a parenthesis inside another parenthesis. That's not the case. You can use as long as there's a legal structure. In this case, we have used parenthesis, 5 plus 5 multiplied by 10, and the parenthesis is there. And then plus added to that number. Hence, if you save it, come back here and execute the code, now you see the answer is where is the answer? 55. Okay, the answer is 55, the last one. That's because it's going to again do multiplication first. 5 multiplied by 10 becomes 50, and then 5 is added. So always remember, if you are solving a program in programming, that problem will always use operator precedence. That's, I cannot emphasize on it. So you could assume that it could be 5 plus 5, 10, and 10 multiplied by 10 should be 100. That's the invalid case. Though you can use another parenthesis. If that's what your target is, if the plus is supposed to be done first, you put it inside another parenthesis. So now look at the answer. So we have 5 plus 5 inside a parenthesis. Whatever is the outcome of this expression is then multiplied with 10. Now the completely answer becomes different. So if you want to do that, make sure you use parentheses widely in programming. If you don't need to do this expression, it doesn't need to be solved first. There's no need for parentheses here. Multiplication will automatically be done first. Okay, parentheses, as we say, has the higher precedence. That's operator precedence for you. Then we have something called relational operators. Okay, let's talk about the relational operators operators. What do we mean by relational operators? Well, let me put a comment here, and then I can say relational operators are basically logical operators. Logical operators that return a Boolean, Boolean value in form of true or false. So this is where Boolean data type comes into play. So what are relational operators? We have a symbol called this. This is known as greater than. Then we have a symbol called less. This is known as less than. Then we have a symbol called greater than equal to, which is greater than equal to. Then we have expression less than equal to. Okay. So now let me just correct this. Okay. Now what exactly do these symbols mean? Well, this symbol again says greater than. This means that when we evaluate an expression, it does a relational evaluation. Okay, that's why they call relational operators. They evaluate the logical condition. Based on that, they return a Boolean value, either that relation or that logical condition is true or false. So let me show you exactly what I mean. So for example, we have system.out .println, and then we can say 5 greater than 10. Okay, so now what we have written here is this is called a logical expression. Okay, this logical expression meaning that it's going to evaluate logically, not arithmetically, logically, using something called a relational operator. So this is relational operator is going to use, and we are using a logic. By logic means something that's creating a decision, evaluating certain situations technically, and then based on that, it gives us a feedback. So that's why we call it a logical expression. So this logical expression is not going to evaluate, is this value that's been written here greater than this value that's written on the right hand side. So is left hand side greater than right hand side? Greater again means bigger value. So this operator here represents the greater than value. If I execute this, the answer here will be in form of true or false. So now what we get false value. Why this is false? Because the condition or the logic is false. So when this expression is evaluated, the answer of this expression, this relational expression, is always in form of true or false. Okay. That's why we have Boolean data types in Java, because in memory, this expression is saved as a Boolean value. Okay, so whenever we do arithmetic operations, the value or the resultant of this is saved as an integer. If there's a decimal, the number is saved as a double or a float. So data types matter, but then those data types also matter with respect to memory. So when you process the data, the value is actually saved inside the memory as well. So that memory also needs to know that what type of data it is. Based on that, how much memory is going to be allocated to that particular data type. Okay, so that's why we so this is what we say. This is a relational operator. This is a relational expression or a logical expression. Again, there are different terminologies based on which programming you're using, but generally they are all same. We call them a relational. These are relational operators. They are logical expressions or relational expressions that evaluate a condition. Condition meaning that is value of 5 greater than 10 based on this expression. Similarly, then you can write, for example, again system dot and dot out dot println, and we're going to say, for example, 50 is less than 5. Okay, and then we close it. So now again we have written another expression called 50 is less than equal to less than 5. So now we are checking, is this value on the left hand side less than the value on the right hand side. So left hand side is always compared with the right hand side. So this is less than, whereas equal to, less than, equal to are evaluating this equal expressions. Means, for example, if I just change these both to 5 equals to 5, now if I save it, Control S, come back here, execute the code, see the answer becomes false. Why is false? Because 5 is not less than 5. It's in fact equal to, the both values are same. So technically they are not less. But how about if I change it to greater? Is the value of 5 greater than 5? So if I change execute now, okay, if I execute the code now, again I get false. Why? Because again this is not bigger than this value. They are supposed to be same. So there are numerous situations where we come across these situations. The both values are same, what we should do. So this is where we exactly use this thing, greater than equal to. So is the value of 5 bigger and equal to this, or is the value of left hand side less and equal to this? So now basically it's going to evaluate two conditions. Okay, then third one we use is equal to comparison, which is actually going to check single equal comparison. Okay, equal to comparison. So are these two values exactly same or not? So if this becomes the case, it will return either true or false. So this is what a logical operators allows us to do. Then after the logical operators, we have something called logic, the and nor operators. Okay, so we call them logical operators operators. These logical operators are basically and if I use this, this is called and then we have something called this sign, pipe sign. The trend does this starts for or. Okay, now what and or basically means that and will evaluate both sides of the condition, and then it will ensure if both are true, only then is done. So for example, if I use, just copy this thing, Control C, come back here, Control V, and if I use this, for example, is 5 greater than equal to 5 and 5 is also less than equal to 5, for example. Okay, so now what should we get? So if I Control save this, and now if I just gonna print one more Control V here, and I'm gonna just use this thing here, inverted quotations, and I say logical operators operators. Okay, Control S, and then I execute the code. So now logical operators, after this line we get true. Okay, this basically means that it's getting a true value. So we are getting a single answer, but we have written two expressions here. 5 is greater than equal to 5 and 5 is less than equal to 5. So technically we should have two values. We have written two expressions here, but because of this and, actually this whole becomes one expression. So what this is going to do is it's going to evaluate this expression. Whatever is the answer of this, either true and false, then it's going to evaluate this expression. Whatever is answer of this, true and false, then these both expressions are again going to compared together. So the result of this expression is going to compared with the result of this expression. And if both are true, only then they will return true. If then in any one case, for example, this becomes 15. Now we say 15 is less than equals to 5. So this becomes false, right? So if I go and execute the expression now it says false. However, 5 is greater and equal to true. So this is true. But because we have used and here, this is going to say, and I need this expression to be true as well. So until both sides become true, this will again return false in all in conditions. So in this case, because this left and right hand side is false, so it's going to end. So and logical operators are actually used to evaluate two or more than two conditions. So if I have a third one, I can use and again here and evaluate another condition. So for example, I can say 10 is equals to for example 10. Control S. So now you see we have expression A, we have expression B, we have expression C. So now we are using three different expressions and we are separating them with AND. So what AND will do, it will ensure that the result of all of these three expressions together must be true. Then it will return true for us. Otherwise, if any one of the expression is false, this is going to return false. By together meaning this expression should be true, this expression is going to be checking is this true, this expression is again. So all expressions, once they return true, only then I get a true answer. Otherwise, I will still be getting false. Okay, same goes with the OR. So if I just control C, copy this, paste it here, now I've only changed the end to this pipe sign and changed this end to a pipe sign. This becomes OR. What OR means, just like in English word we use, hey, do this or do that, right? So either one, we give an option. In the same case in programming, now we have said, is this expression true? Or is this expression true? Or is this expression true? So if any one of them becomes true, the answer eventually becomes true for us. So if I come execute it, now it says true. Okay, so the first one was false, and but if I change the operator to true, now the condition becomes false. So it's going to say, hey, 5 is greater than equal to 5, condition is true. So it all needs this. So it says, true, this is okay. Then 15 is less than equals to 5, this condition becomes false. Okay, then it's going to 10 is equal to 10, this again becomes true. So now we have three expressions, two of them are true but one is false. Doesn't really matter because we have used an OR operator, it only needs one true condition. So what happens if I change this to 100? Control S. Okay, so now this should be false because this is not equal to this. This should be false, not equal to this. Only this one will become true. Okay, so if I execute the code, now it says true again. Why still true? That's because it's again, it just says either this one is true or, so it just needs any one of the part, any one of the options to become true. This becomes a logical OR operator. Okay, and then collectively it's going to say they make a decision on all of this, that if this is true, either one of them are false, doesn't really matter, I will give you a true answer. Okay, how we exactly use this? We use this in something called conditional operators. So now let's talk more about something called conditional OPE or conditional statements, in other words STATE statements, which are known as if else. Yeah, ELSE. Now this is where the true logic of the code basically starts. Okay, this is where we start to write a code that makes more decisions. So for example, I create a variable integer time is equals to 20. Okay, and then I use a very something called if blocks round brackets block start block close. Now what we have done here is a simple condition that we have wrote, and then we're going to say, hey, is time less than 18? Okay, if that is the case, then what you're supposed to do, you just let me just control V the previous one, and I'm going to say hello oops good time. Okay, and if this condition becomes false, I'm going to say else, else, and then I'm going to print a statement, and this time I'm going to say, well, listen bro, oops, control Z, let me just kill all of this, and I'm going to say not a good time. So now what I've done here is I've used a simple if statement. This if statement will evaluate a condition just like the relational operator does. So but the difference is this evaluate a condition. If the condition is true, it will execute a block of code. Okay, if the condition is true, it will execute a block of code. Else, if this becomes false, then the control will go here in else and execute this statement. So if and else statement are known as conditional statements, they allow us to make decision in our system, in our programming, and that's where our true logic starts to kick in. So using if else statements, we make decisions in our system. If this condition becomes true, then you execute the system, and the condition is again based on these relational operators and the logical operators. Okay, so this logical and the relational operators we use now primarily within if else. So we say if time is less than 18, you're supposed to say good time. Else, if this condition becomes false, this line is completely ignored. Now this block of code is completely ignored. and the control from this condition will go to else, and this statement will be executed. Control S, execute the code, and we say not a good time because the condition time is 20. This condition becomes false. Because this becomes false, this line is ignored and the control moves to the else statement. It is not necessary to write else. You can skip this as well. Control S still would work fine. Sometimes you just need to write an if something is true, it happens. If it is not, then there is no output. Okay, and certain times we need that if this condition becomes false, then I need to do something else. Again, as I said, decision making. So we make a decision based on if else statements, and we use this in multiple situations. Then there's a concept of nested if else statement. So we say nested if else state statements. What, how they work is, for example, I can say I have marks, or for example, discount price. Okay, so we can say let's have a variable integer discount, or in fact age. Okay, let's make more sense. So if my age is, for example, 18, now I'm going to write a system that allows me to write a particular condition. So for example, here is task. Okay, I can say write a program to determine discount on ticket based on age. So for example, if my age is equals to less than 12, then I will be like 25% discount. Okay, in fact, let's just make it 75%. So if you're a small child, if your age is less than 12, you get what we say 12% discount is equals to 75% discount. However, if your age is between, let's just say, for example, 13 to 18, you get something like 50% discount if I'm generous. And then if your age is, for example, above 18, you just get like 10% discount. Rapish. So we have now this three different conditions to evaluate. So if I have a program that needs a discount based on user's age, and this is what we're supposed to do. So if you're less than 12, you get that, even though we can have it even more specific things, more customized and depending on what condition you want to do. So now if I write a program, I'm going to use nested if else. So I'm going to say if my age is less than 12, okay, what should happen now? So I'm going to say system dot out dot println, okay, and then I would just use the statement you get 75% discount, semicolon, and then I'm going to say, hey, listen, else. But this time, instead of just writing an else and statement, I'm going to write another if statement in front of the else. What this basically means that now I'm writing and giving another condition inside the else statement. So I'm going to say if age is greater than equal to 13 and age is less than equal to 18, then I'm going to say, listen, bros, if that's the case, then you get what we call, system dot out dot println, and then you're going to have what we call you get 50% discount. Okay, and let me just put the word discount here as well, making a little bit more sense. Control C. So now but this time and, again, if you write and in English, it's going to complain. So make sure you use the and operator, proper one. So now we have written a simple nested if else structure. So the code or the logic is that if I need to do this evaluation, I'm going to check the value of age. If my age is less than 12, I need to have 75%. Less than, so I can say if my age is less than, in this case, let's make it equal. So if you are 12 or less than 12, you get a 75% discount. Now note one thing, I have not used block of code here. Okay, these brackets are not used here. They are not compulsory. They are compulsory in only that situation when you have more than one statement in your block. So for example, if I have two statements, okay, then I would need block of code. But if you're just going to print one line, you don't need to write the block of code. Same goes for the else as well. So since I have only one line under the else, I don't need that block of code. But if I need to print multiple lines inside this else, then I have to use the block of code. This block indicates that this entire code belongs to this else. So same thing goes here. If the condition is true, this line will execute. Since I'm going to print only one line, I don't need to use the block. But if there were more than one line, then I must use a block of code. Okay, so I must use this block to indicate that, hey, when this condition becomes true, execute the entire block. But if it's a single line, you can just use it without the if thing. So in this case, I say if this condition is true, execute this thing, and everything below it will be ignored. All the code that's associated with if else will be ignored. It won't be executed, it won't be checked, nothing will print it. If this first if becomes true, if this becomes false, only then the control from here will come to this else, and this line is completely ignored. It's not going to execute because the if becomes false. Inside this if, after a space, we have written another if statement. So now it's going to say, hey, if age is greater than 13 and age is less than 18. So now we are evaluating two different conditions, two different expressions. Age must be above 13 and age must be below 30, below 18. So now AND operator is most important because we need to ensure that my age resides between 13 and 18. That's why AND operator is here. That's why we need equal to operators as well. If this becomes true, execute this statement. If it's false, okay, we're going to say hello else, and then we write another if statement. So this is what a nested if else means. So we have if, else, inside else we have another if, inside this if we have else, and then again we have if. So this creates a box inside a box inside a box kind of a structure. So check one condition. If this is not true, go check other. If this is true, then go here. If this false, go here. So it creates a hierarchical structure of what's going to happen. So now we're going to say if age is greater than 18, okay, oops, 18, then basically what you're going to do, you're going to just print this statement, and you're going to say, listen man, you not good time, you get for example 10% discount, discount discount. Cool. So now we have used this same conditional task to evaluate our expressions in programming. So this is how programming basically works. We evaluate certain conditions, we make decisions. Based on our decision, we evaluate the expressions. And that allows us to work more prominently checking things. Okay, so Control S. If I execute the code, we say, hey, you get 50% discount. Congratulations. But if I set my age to, for example, just 1 year old, and if I run the code again, it's going to say, caused by error. Okay, sorry. Make sure you have not selected anything. So you get 75% discount because your age is less than 12. So if this is the one, this condition becomes true. It prints this line and then comes out of here. So all of these lines are completely ignored and not even executed because the first if became true. If my age is, for example, 21, Control S, and then if I execute the code, now what happens is that it says, hey, age is 21. So age is less than 12, condition becomes false, control goes to this else. Then checks, hey, there's another if here. Okay, so is the age between 13 and 18? Condition again becomes false. He's bigger than 13, but he's not less than 18. I have set a range here. So this again becomes false. So from this if, the control goes to this else. Inside this else, we have another if condition. And then we have a system here. If you want, you can use another else here. So I can say else, and then this time I don't need any condition, and I'm going to use again system.out.println, and I'm going to say, for example, enter number between 1 and 100. Okay, so that's basically my statement. And then semicolon. So make sure you put semicolon at the end of everything. So if age, if I enter a very invalid number, for example, 121, so it's going to check false, false, false. Finally, if everything else is false here, this else will execute. This else does not contain if. So if this is false, then this will be executed, and since there's no condition, this statement will execute. Okay, so this is what if else statement allows us to do. Hopefully that makes a little bit more sense, right? Now moving on further, let's talk more about something called a switch statement. Okay, so what do we mean by SWITCH, switch, STAT statements? Switch statements works in a very funny way, but they also are used for conditional operators. So they are type of what we call conditional statements. However, they are not in specifically working with respect to if else. Okay, because if else is more powerful for me, and they have more control over the evaluation of expressions. Switch, in other words, just does a very basic comparison. So for example, if I use integer day is equals to 1 semicolon, then I use switch switch, and then I have used the value called day. Okay, block of code start, block of code ends, and then I'm going to say, hang on, there's going to be something called day. In fact, day, if it's 1, and then you're going to use system dot out dot println, and then I'm going to say if day is 1, just use something called Monday, for example. Okay, control C, and then I use this thing. So then I come back here, sorry, break, and then I'm going to say case, if the case value is 2, then what you're supposed to do, you're supposed to print system.out.println, and then going to break, hit a semicolon, and then instead of Monday, go for TUES, Tuesday. Okay, so now what's happening here is, let me just copy this code and do one more repeat so we get a little bit more clear sense of what exactly we're trying to do. Okay, WEDNES Wednesday. Okay, so now again, switch statements are conditional statements. They evaluate a condition. However, this condition works in a very specific manner. That specific manner is that the switch statements always check value between 1 and, okay, between sorry, go somewhere else, not 1 and 7. They always evaluate equal to comparison. Okay, so this equal to comparison is where we evaluate the expression, that whether this expression on the left hand side is exactly equal to the expression on the right hand side. So this is double equal to operator is used. Switch is by default always only double equal to. So if I say integer day is equals to 2, and then I use switch, again, switch word is a keyword, reserve word. You cannot use a switch as a variable name, as a class name, as a method name. And then we pass it this argument value day. Okay, then block starts, block ends. So do remember, in programming we have a blocks, and certain times blocks are important. In switch case, you must use this block of code. So this block indicates that this entire code after this block actually belongs to this switch. Then switch uses another keyword called case. Case again is Java's keyword, Java's reserve word. You cannot use this case as a class name, as a variable name, or a method name. Keep in mind. Now what it's going to say, it says I have a switch. So it's basically an equal to comparison, and I'm going to compare it with this value here. So day, if day is set to value, whatever value it is, whatever option is inside this, equal to 1. So case can be read as equal to. It makes a little bit more sense in my head if I want to explain. So what switch does is that you give it a value a, and then case is actually considered as an equal to, and the value that's given in front of it. So day equal to 1, day equal to 2, or day equal to 3, or day equal to 4. If this value is true, then system, it will execute this line of code, and then we need something called break so that it stops the execution and comes out, and then doesn't need to go and do any more things. Understand? So similarly, if I set a value to 2, it's going to say that the value of day is 2. So case means again equal to. So day value is equal to this one value. If condition is true, if this becomes true, Boolean value comes true, this line of code executes. It breaks. Again, break is a keyword in Java. It's a single purpose function that stops the execution flow. So it just stops here and takes the control out of the block. Why it is there, I will explain in a moment. If this condition is false, these two are not equal to each other, then the second case is there. Now it evaluates day value. The value inside this day variable is equal to this 2. This becomes true. It's going to execute Tuesday. Control comes to the break. It's going to break the execution flow and then come out of the block of code. Control S, execute the code, and you're going to say Tuesday here. So this way we can have multiple equal to comparisons very easily, very equal to, no, very easily. So for example, I have 2, 3, and I can say, for example, 4, I can have 5, and I can have 6, and then I can have 7, and that should end it. Okay, so Monday, Tuesday, Wednesday, and then we can write a code THURS Thursday, and then we can say hello, this should be like Friday, this should be like SATUR Saturday, and then this finally should be like Sunday. Okay, now imagine doing the same thing with if else. So you would have to write if day is equals to 1, print this. If day is else, if day is equals to 2, print this. Else if day is equal to 3, day is equal to 4. So there will be 7 times you have to write if else, if else, if else, if else, if else, if else. So the code becomes a little bit complex to read. However, if you do it in switch, it becomes much easier to understand and visualize what exactly you're trying to do. So that's why if there's a straight equal to comparison, this code basically works in a much easy to read manner. Make sense? Exactly. So now it's going to compare this thing with each of these cases. If the value matches, this case executes, break will break this execution. However, if you don't use the break, okay, so if I delete the break from all of these lines, if I delete the break here, control S, and then if I execute the code, see what happened. It printed Tuesday, which makes sense. Okay, the value is 2, so it evaluated the first case. This became false, so this was ignored. Again went to the case 2. It says case 2, day value is 2. This becomes true. It executed this code, but it did, then what it did, it went on and printed as well as Wednesday, as Thursday, as Friday, as Saturday, up till Sunday. What the hell here? Because as per switch and case statement, if one condition is evaluated as true, then switch assumes everything is true. And see, this is not ending with a semicolon, this is ending with a double colon value. Double colon means this is not an end of statement, it's just a part of first statement. So because it's not end of a statement and there's no block here, if any case becomes true, everything below it becomes true, because now it will not reread these cases. So these cases are not reevaluated once any one case is true. So that's how it basically works. So if your case becomes true, assume that everything below it will now be executed and will be considered as true. And that's why we get all the days printed here now. That is why in this case, we need to write something called break, break, break. Oops, oops, oops. Control, okay. Did I do something different? Case 6, what happened? Oh, okay, control Z, control Z. I use a different shortcut. Okay, control Z, control Z, control Z, control Z. So that's why we use break, that if this case value becomes true, execute whatever or how many lines we have written here, as many as we can write. So whatever lines are written here, execute them, and then in the end, just break it out in the code. So this is what break does. So whenever we are doing equal to comparison, breaks makes much more sense, and it is just there wonderfully to explain things easily. Okay, let's move to next topic. So after these conditional statements where we make logical decisions, now we need to talk about something called looping statements. Okay, wonderful. For example, we have something called a while loop. So what do we mean by looping statements? Okay, let's talk more about that. Looping statements are basically statements that loop itself until a condition is satisfied and becomes false. Okay, so for example, we write a statement like integer, and we can say I is equals to 0, and then we start with the while loop, round bracket start, round bracket close, and we say I is less than equal to 10, block start, block close, and then we're going to use same system dot out or println, and then we say the value is, and then plus, and we print the value of I. Okay, so now what happened here is that we've written a looping statement that's going to basically loop itself until this condition is satisfied or becomes false. Okay, just like if else, if only evaluates the condition once. If the condition becomes true, it executes the block and then exits. If the condition becomes false, the else statement is executed. However, looping statement does the same thing, but it will keep on repeating itself until this condition is either true and it executes, and when it becomes false, it stops the execution. So what we need to do now is we need to ensure that this variable value is keep on changing itself. So now we use something called an increment operator. Okay, increment operator behaves like a +1 thing. Okay, so for example, this would be evaluated as I is equals to I plus 1. So this is a shorthand operator that does this operation. Take the value of I, the current value of I, add 1 to it, and whatever is the answer, assign it back to I. Okay, so this is what we call a shorthand operator, in which we write this expression in a shorthand way. I plus plus, and there's I minus minus as well, decrement, which means I must subtract 1, and this is quite useful actually. So now what we've done, we have said take the value of I, set it to 0, Then while I is less than equal to 10, so it's going to say I initial value is 0, is I less than equal to 10, this condition becomes true, it will execute this block, then it's going to execute this line of code, then it will automatically repeat itself. That's what the repeating does. If else only execute once and exits. The looping statement like while, for, and do while, these are three statements that we use. We say while, we have for, and then we have something called do while. Okay, they are known as looping statements that will repeat itself until this becomes false. So that's the key thing here. And if I execute this control S and execute the code, you would see the value is printed multiple times. The value is 0, the value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when it becomes 10, this condition becomes false, because after that it becomes true and the looping statement exits. That's how they basically work. So it will initialize the variable, check a condition. If this condition returns true, it will execute. And then if the execute this block of code, once it executes, it then goes back to this control. Again, check the condition, execute the block, check the condition, execute the block. This is how they basically work. Then we have something called do while statement. Okay, the do while works with this syntax. So if I write the same thing, integer, this time I2, or maybe we can say let's just make it I2 for convenience sake, and I'm going to start it with 0 again, and then I will say, hey, let's write do block start block close, and then I'm going to use the same line of code, control C, control V, and then this time I will just make it I2, and I will make this I2. After the while we write, after the do block ends, we write while, and I'm going to use the same expression, I less than equal to 10, and then there will be a semicolon here. So this is a little bit different syntax, okay, does the same thing almost, except one major exception. It's just the writing way is different. The do while is that you write the do, again do is a keyword reserve word, while is the reserve word keyword, you cannot use it as a variable name or class name. So we write a do, block start, block close, there's a block of code here. Then after the block ends, we write the while statement, round bracket starts, again an expression, and then we end it with a semicolon here. Here there is no semicolon, just block starts, block close. So typically this makes more sense. But this is like, as I said, a different way. The key difference is in execution. Because we have written the statement before the condition has been evaluated. So this will execute at least one time. This will execute at least one time. So for example, if I set it to 100, okay, and if I execute the code, so you would see this, the value is 100. This has been printed. The value of do while is, if I make it more clear, and then re-execute the code, so the value of do while is 100. But this only executed one time. Why? Because a value of I is 100. It will come here, it will execute this line of code. So this got executed, then it did the increment, then it checks the condition. So in this case, the statements get executed first, and then the condition is evaluated. If the condition is true, then it will again loop and re-execute, do the increment, and change the check the condition. In a while, it actually checks the condition first. So if the condition becomes false at the first go, it will stop the execution flow and it will no longer execute it. Okay, so that's the key difference. So do at least in any situation will execute one time, which can be used in certain situations. So that's why we have that purpose. Okay, then third loop, we have something called for loop. Okay, for loop. The syntax or the way we write for loop is we write state statement semicolon, then we write another statement, okay, state statement, again semicolon, and then state statement, and then we have a block of code. Okay, this typically becomes the syntax of our for loop. If I just control X and make everything comment so we can understand it. How we mean by that? So for example, we write for round bracket starts, we write integer. This time it can be I3 is equals to 0, semicolon, I3 less than equal to 10, again semicolon, I3 plus plus. The increment is now I've written here, block start, block close, and then I just copy this statement here, control C, paste it, and then change this from I2 to I3. And this time I will use the value of this thing, control S. Now what we have done here is we have written the expression. So in this case, previously, remember the integer variable initialization was done before the loop. This is not necessary. It depends on what variable you are using here. But in this case, it's been written before the loop, then the statements, and then the increment is also necessary because we need to ensure this value changes, and at certain point it becomes false. Okay, then this is how it works. In for loop, we write everything in one line, and this is why it's most commonly used, because it just makes a little bit more sense. So we've written integer I is equals to 3, I3 is equals to 0, sorry. Then we check the condition, again semicolon here. Do note there's a semicolon inside the round brackets. I believe that's the only time that it is there. Usually if there are multiple values, we use comma, but this is the only time we use semicolon here. And then we do the increment, and the block of code executes. If you press Control S, execute the code, see this, the value of off is basically this thing. So again, 0, 1, 2, 3, 4, 5, 7, 8 are printed. How this is working, it will initialize this statement, and this part of statement, or this first statement, for example, if I say statement 1, statement 2, and then this becomes statement 3, this executes at least only one time. That's it. It will only execute one single time. Then it will evaluate the condition. If the condition is true, it will execute the block of code. This line is skipped for the first part. This third statement is skipped for the first time when it executes. That's how the for loop works. So you need to understand the structure that's just going. So it executes the first statement, checks the condition, then if the condition is true, the block of code is executed. Then it goes and evaluates this I3. So the next time the loop loops around, it will do the increment, change the value of I3, check the condition. If the condition is true, execute the block. Then do the increment, check the condition, execute the block. So this line only executed for the first time. When first time loop executes, this part only executes one time. Then we have a condition here. This condition is evaluated, block the statement is executed. Then it does the increment. So this is what the looping statement does. Now I told you we need to be careful that, and why this I plus plus 3 is there, because we need to be very careful. I can write a loop in this manner. For example, I can write true here, because remember, these expressions will always return a boolean value to us. So while actually needs a boolean value in form of do while. This while actually needs a boolean reply. If it's true, it will execute. If it's false, halas. So this expression allows us to get that conditional true and false value based on that condition. You can, however, write true here directly as well. Makes perfect sense, because while needs true, it's looking for a true, and to achieve that true, we use that logical expressions. But if you write directly true, works fine. In this case, we have written true here. This is an expression. What happens now? So what we initialize with 0. The condition is there. Condition becomes true. It will execute the block. It will do the increment. Condition is again true. Execute the block. Do the increment. Condition again true. Again true. Again true. This will become an infinite loop. This will become an infinite loop. It will execute forever. So that is why we need a condition, and we do an increment to ensure that at a certain point this loop stops its execution. If you don't do that, now we end up with a permanent loop. So in case of while, for example, if I write true, this means that it's going to execute forever and ever and ever and ever, because every time it's going to need true. In cases that we do is, oops, control Z, even though if I've written an expression, but if I don't write the increment statement, that means that I'm never changing the value of I, because the value of I is never going to be changed. Every time it's executing, it will take I is equals to 0, less than 10, true. Statement is executed, but there's no increment. Next time, I is again still remains 0. So say 0 less than 10, that's true, agreed. Again and again, so it becomes what we call infinite loop that never ends, and it will struck your program. Okay, so this becomes a huge error. So that's why we need these increments, so that this value gets changed at a certain point, and then eventually becomes false. How we use looping statements? For example, I can do this thing. Now let's just create a table. So I said task, create a program to print table of any number. So I said, okay, no problem. Let's just create integer table is equals to, for example, I want a table of 5. Now I'm going to use for loop, and I'm going to say integer I, for example, number num is equals to starts from 1 semicolon num number less than equal to 10 semicolon and then let's just make this number plus plus, so it does the increment. Once we are here, block of code added, so we need this block of code every single time. Then I'm going to print this, say, okay, now we need to print the table, so I'm going to use system dot out dot println, and because I need to print the number, so I'm going to say hello table, then plus, then invert string, and then just X mark. Okay, and then I'm again going to say, and let's just add some space between these space marks. Then I'm going to say plus this number variable. So table will be, for example, 5 multiply by number is 1, so 5 multiplied by 1, again plus inverted quotations, I use this equal operator, then again plus, and now I'm going to do table multiply by number. Okay, so it's going to give us this answer. But now if I just leave it to this point and I execute the code, see this, we get this value. 5 multiplied by 1 is equals to 5, 5 multiplied by 2 is equal to 10, 5 multiplied by 3 15, 20, 25, 30, blah blah blah. Why happens? Because first we printed the value of table, so table value is 5, so 5 was printed, then plus added with this string x, so this string x is printed here, then number, so this number 1 2, so whatever value is changing here gets printed 1 2 3 4 5 6 7 8 9 10, plus multiply this as a string is printed here every single time, same equal to, plus table. Now because this has a multiplication, remember we talked that multiplication has a higher precedence, so this will execute first before this plus. So this table multiplied by num, whatever is the answer, will finally be concatenated with this. To make it more simple, you can write this inside inverted brackets as well. Okay. So if I write it brackets, makes more sense. So add multiply by a table multiply by number, do this multiplication, whatever is the answer, added with this final value of string. So we get this thing. So see, just writing couple of lines, we are able to generate table of 10. But if I change the condition to, for example, 20 now, okay, if I say 20, control S, hit that loop, now I get table for up till 20. So you see this big line. These are what looping statement allows us to do. It allows us to customize and print multiple lines of code by writing as minimum line of code as we want. So we have a huge number of output through our code, but I just write 3 lines of code. So that's what looping statement does. So it allows us to repeat itself, check some data. For example, there are 1,000 files that I want to read. So I don't have to read every single file. I will just loop through different files. If there are 1,000 records in my database and I want to read all that database, I will just use a loop to go and reach each single record and do whatever operations I want them. So only writing a few lines of code, I can do same repetitive tasks again and again. So yes, do keep in mind that looping will try to repeat itself again and again and again and again. So it depends on what values we are changing. Okay. Okay. So now let's talk more about Java methods and Java classes and some of object-oriented concepts. Now let's just create a new file. First of all, as we have already talked about, we need to create something class. And I say, for example, my metho methods, or for example, let's just make it a student class. A student makes more sense. So we're creating a student class. Okay. And as we know, every class needs to have something called public, and then it needs to have something called static. It needs to have a return type, and then we're going to declare the main method. It needs to have an argument called a string and any other variable name with the array sign. And now we know what this array means. Okay, so this is a standard C Java code. Let me just zoom into it. I think we need to kill this one. No need for this. Okay, so once we have that, now this is a typical class. Okay, up till now we have been doing all our work inside the main method. Now this is one method, but we can create our own methods as well. And usually I like to do it after the main method. Just makes things a lot more easy for me. Some people like to do it before that. Again, everybody has its own preferences, how they want to code. So for example, if you want to create your own method, again, we're going to write something called void, and then I'm going to name him, for example, get name. Okay, and then I'm going to bracket start, bracket close, bracket start, bracket close. Okay, now this becomes a typical syntax of your custom method. Again, providing a return type, meaning that when this method executes, it will not give me any reply or no answer, or in simple programming terms, it will not return a particular value. Then we have a method name. This becomes my method name. Any name is valid here as per Java rules. For example, you cannot use number to start a name. You cannot have a spaces. and you cannot have any special keywords that Java has reserved for themselves. For example, if, void, main, static, public, class, all these are keywords. You cannot use them as your own method name. Then every method needs to have what we call bracket start, bracket close. We pass number of arguments here. I'm going to talk about it in the next method. And then we're going to start the block of code, and close. This is typically what we call a method signature is. Okay, this is a syntax of method. Every time we create our own method, this is how we do it. So for example, in this case, I'm setting get method, and I'm going to use something called string, sorry, not string, system dot out, and then I'm going to say dot print ln, and then let's just use a semicolon here, and then inverted quotations, the name of student for this method. So this becomes my one method that whenever I want to execute this method, it performs this task. Again, method can be considered or is usually defined as a set of instructions, or it's a block of code that performs a specific task. So whatever you write inside this is supposed to do a specific task. In our case, we're just saying get name. Okay, and it's going to print our name. But for now, we're going to leave it to that particular point. Then I can have another method. For example, in this case, I'm going to say string, or let's just use again void for this method, and then I'm going to say set name. Okay, and then bracket start, bracket close, and then I'm going to say, hey, I'm going to pass this as an argument, and I'm going to use a variable called name. Then we'll explain in a moment. And then I'm going to say system dot out dot println. Okay, and then I'm going to use this thing, and I'm going to say the student new name is, and then I'm going to use plus, and I'm going to use this variable. Now what I've done here is I've created another method. Now do note, every method starts with a block of code and ends a block of code. You cannot declare the method inside a method. Okay, so because this is a method, this is a separate method, each method needs to be on a new line, on a separate block of code level, so that this block ends here, and only then you can start a method. As I said, typically I usually write this comment. So for example, end of get name method, the method. That way I know this method ends here. And then you can have hundreds of methods in your code, and writing these comments can be very helpful. If you have like hundreds of codes of lines inside your method, you don't know, hey, I started here, I don't know where this method ends. But this kind of instructions helps programming a lot. So do keep it a habit of it. Now I've said two methods here. One will both prints a very simple line. Again, a method is considered as a block of code. Each method needs to have a statement. So how do we use these methods? Very simply, in order to use these methods, now we need to create something called object of a class. By object of a class, we mean that we create a variable using this class name. And then for example, I can say std1 is equals to, and I'm going to use new, and then student block star block rows, and that's it. So this is what we simply typically mean, object of class student. Now what exactly do we mean by object of a class? Previously we have been talking about variable names. Okay, each variable basically is, for example, declared with a particular data type, having a variable name, equals operator to assign a value, and then a value itself. So this is called a variable declaration, where we declare a variable and initialize it with the value 10. Similar to this, we create a student object. The difference between is that a variable holds a single value, only 10, and it occupies a standard memory called integer. Because of integer, it holds a 4 bytes in memory. Okay, it's a data type. We know this only has a student data in x integer data type. When we create an object basically represents your entire class data. So when you create an object of a student class, basically you are creating a representation, an instance of your class. So an object is considered as an instance of a class. In other words, it's like a entity that holds all the data about your class, simply speaking. And in the data, we mean the methods that are existing inside the class. Even the main method, even this method, now all of these methods belong to this std object that we have created. Okay, all of these methods, and there can be hundreds of methods in this class, all these methods now are part of this std class object. Okay, so this object is the instance. Because this is an instance that of student, what is a student? A student is my class name. So I've created a class, and then I have created an object of this class. So because I'm creating an object of the class, I use the same name as my class name. That is why we always try to save the same name with the file name as well. So whenever we saving the Java code, we always use this name of the class. So in this case, my class name is student. So when I go and say file, save this code, I will make sure that I save it as capital student student.java. Okay, so Java is extension. The name of the class has to be same, because when we create object, it needs to know which class it belongs to. So we say student std is equals to new student. So now we have created an object of a class. If you save it as object one, you can still at one point create an object, but in order to execute this code, Java's virtual machine needs to know where this student is, because using this student, it's going to access this main method. Okay, so that's why we save the class name with the file name. They need to be same. Okay, so that's why once we have a student, we save the same class name as a student, because when you execute the code, the JVM, the Java virtual machine, needs to know that this main belongs to this class which is inside this file. So then the name coherence is quite and absolutely important for the main method. We can create multiple classes that do not have main method. For that, we can have another way of working with it. So you can change the name there. But in this case, we're going to stick with it. So now we say, hey, this is an object. What can now we do with an object? Object can access any methods, any data of this class. So this object can now easily access get name, set name methods. Okay. So the syntax of object is that we use the class name. Again, this can be considered as a variable name, but because this now behaves like an object, we call it an object because it holds multiple data. Instead of just one single variable value, it holds the complete methods and functions and multiple data. So that's why it's not considered as a variable, it's considered as an object because it has many data. Then equals to, and then we use a specific syntax called new and a student, same class name, and then bracket star bracket close. This in fact is referring to a constructor. I'm going to talk about it in a moment. Okay, but actually this is a part of it. So new keyword will tell Java that we are creating a new variable name. Okay, we are creating this new variable, a new object, and assign that object value to here, and this constructor is basically a part of this. Do keep this word constructor in mind. I'm going to explain in a moment what it's going to do. Now in order to use the data, we're going to say std1, and we're going to use dot operator. Using the dot operator, we can say get name, and we call this function semicolon. What now we have done here is we have said, hey, because this is an object of this student class, this object consists and possesses access to all its metadata. So now what we're going to say, use this student object. Dot is a connection operator. It creates the connection between an object and the data that it belongs to. Okay, so the data of that class of which this object is. So it creates that bridge. Actually, it creates like connection. So student std1 dot create a connection and go inside this class, find me this method name get name, and execute it. Now this is method declaration, as we call it. Remember, we talked about in variables as well, that when we declare a variable, we have integer y. This is called variable declaration. And then when we say y is equals to, for example, 10, this now behaves like a variable initialization. So this is what we call a variable declaration. Okay, and then when we come here, we have something called variable initialization. Okay, oops, I spelled it wrongly. Initialization means that we initialize a variable, we declare a variable, and in this step both have been done in a single line. Same goes here. So when we set this get name, basically we are declaring the variable. So this is called declaring method, or method declaration, as you want to say it. Okay, so we have declared a method that what this method is supposed to do. Its syntax goes with return type, method name, bracket start, bracket close, block start, block close, and then the code that we want, or actions or statements that we want to write inside it. This is what we call method call. Okay, so we say call to method. Call to method means now we are calling this method that is declared inside our class. That's how we put the technical terminology into place. So we are calling the method that has been declared in my class using the object dot get name. Without this object, we cannot access these methods. These methods specifically belong to this is student. You cannot just simply write this capiche error, because it does not know where this method is coming from. So that's why we say object oriented programming language. When we use the terminology object oriented programming, it means everything is considered and looked through the eye of an object. Okay, everything goes inside object. All the data, the method you must write inside a class. Then in order to use that method and data, you need to create an object, and that object will have access to it, and then only can you actually use it or call to it. So that's the fundamental concept of object oriented programming. Everything is considered as an object, and the data is inside that object, and that data has been declared inside a class. Understand? Hopefully. So now when you execute this code, Control S, and if I try to execute it, if everything goes as per plan, the name of the student, this string gets printed here. Okay, I said okay, perfect, no problem with that. However, I want to again, we can, if you want to use the set name method, so let's just come here. I want to do std1 dot, and I'm going to use the set name, but this time what we have done, we have given it an argument. This here inside these round brackets is known as an argument. So this method has been declared, but now it needs an argument. This means that every time you want to execute this method, you have to give it some value. You have to give it some value, and only then this method can be executed. So it is like hard coded inside our system that when I use this method set name, I'm going to give it a value. I need to give it some value, some data, some information. So this value in our programming is known as argument. Okay, so we say in this case method method declaration oops dic rat1, excuse my spelling, method declaration with argument. And there can be one argument. If you have multiple, you use comma, and then you use another argument, comma separated values, like we do in arrays. Okay, so currently I'm just going to use this one variable name. So now what this means, that every time I need to use it, see this, it's asking me this name here. Now you see, if you're writing a code in VS, you see these additional pop-up helps. These are telling you that, hey, this set name requires an argument called name, which is actually coming from this name variable. And this name is going to be a string data type. So we use an inverted quotations, and I'm going to say, hello me. Okay, and I provide my name there. So in fact, let's just make it more specific. I am myself doctor, so we say Dr. Zeeshan. So now Control S, make sure you do save the code before you execute it, otherwise it's going to cry out loud. And then now we're going to execute it. So now you see the student name is Zeeshan. What happened here? We used the Zeeshan at this variable name. However, this method does not contain that value, but when we printed it, it got this name. So what's this happening? It's called passing argument values. Okay, so pass by value. What's happening now is that when we use a student object, this all method are now an entity and possessed under this thing. So we set name. So we are calling within our objects this method. Okay, so this method is being called, perfect. But this method requires an argument called string name. So we provided it that inverted quotations string name. Don't worry about this. This has been inserted as a help by VS Code and the extensions that we have installed. I've talked about this in initial topic. So when we pass this argument is going to go to this variable here, and it's going to print this variable's value here. This is what happens in a typical object-oriented method and object calling. Now here's the fun part. Can I create another student object? Yeah. So for example, if I need to create another student, and I'm going to say std2 this time, and I'm going to use the same syntax, new keyword, because every object must be created using the new keyword, and then we use this constructor call and then semicolon. So now we have created another object. So now we say std1 again, oh sorry, std2 this time, because we have a second object, and I'm going to say set name. So we're going to set name, inverted quotation marks, and I'm going to say, for example, John, P-A-U-L, Paul. Okay, so this time we have, oops, I think John spelled this way, J-O, I changed. That makes more sense. So now we have created another student, exactly the same way as then. So this is exactly what we do when we create multiple variables. We use the same data type, we use the variable name, and then we pass the value. The objects are created exactly in a similar structure. We use the class name, We give it a variable name which becomes an object once we use the new keyword with our constructor call student, again being named after the same class name. Now you can create as many objects of this class as you want. However, here's the key difference. This student is completely independent of this student. They have absolutely no direct connection with each other. It's like a typical example we give, like a assembly car. So when a car is designed, its initial design is finalized. Then that becomes a class. So we define a car class. We define the properties of that car inside a class. So it can have tires, the seats, the shape, the lights, the fenders, the hoods, the seats, the sound system, the multimedia system, the dashboards, and everything is defined in the main class. Then we create objects from that class. So when we create an object, we create one model, two model, three model, 4 copies, 5 copies. You can create 100 objects from that main class. Each object will have all the entities of your main class. So all the entities of your main class will be in each of these objects. But however, once the car is finally created and shipped out, each car is completely independent from each other. Okay, that's why you drive your own car, another person can drive his car. They can change the fenders, they can customize it, they can change the seat covers, they can change the tires, xyz, because even though they are same model, they have no direct relationship with each other. They are not connected at all. So that means that student 1 can be Dr. Zeeshan, myself. Student 2 can be John Paul. These are two independent entities, all using or all belonging to the same class. So when you press Control S, make sure you save it, and then you go and execute this code. You would find the student name Zeeshan and the student name. So this same function is now performing two different tasks. The same function set name is setting name Zeeshan for the student name this, and then student 2 is using John Paul. Hence, both objects are printing two different names using the same method. That's the key thing. The method declaration is same. It will remain same. And you can have 200 objects, each object printing and doing their own tasks. They will not correlate with each other. They will do individual independent tasks. That's why we say Java is purely object oriented. Again, this object oriented word is emphasized. Means once you have an object, this object behaves completely independently. Okay. Now, one other thing that we do is within this object and variable declaration is we say, for example, string std name. Std name is equals to, and I set it to null for now. What does this mean? Now see what happened. This is something that we have not been discussed in W3Schools up to this point. That's why I say I'm just going to wrap it up in my own way. Now what we have done, this is what we call a class variable declaration. Okay, this basically means that now we have declared a variable outside public static void main. First thing to note, up till this point, all the code we did was inside main method. This time we declared another method outside the main, then another method outside the main, but at the same time we declared a variable. Yes, in a class, typically there are two type of entities that we can use or include. Okay, each class contains two type of data. First, variables or data. Second being the methods. That's it. Every class in Java, can you imagine, entire code of Java actually consists of these two major components. We have variable declaration, we have methods. So public static void main, method 1, get name, method 2, get set name, method 3. That's it. You can declare variables, as many variables as you want, and you can declare as many methods as you want. So basically it contains these two entities. So this variable is now known as a class variable. This variable is known as a local variable. Okay, so what I can use, the appropriate word is a local variable. Local variable means that this is a variable whose scope is only within the block in which it has been declared. So this actually, it's like a room. So you have a bigger house. Inside a house, you have a room and you have a TV lounge, for example. That's it. And you include the washrooms a part of the room if I exclude that. So saying that, because this is a room, if you declare a variable inside this room, now you can only use it inside this. this variable cannot be used in the second room, in the second method. That's why we refer it to as a local variable. However, this is known as a class variable. This is a variable meaning that if I declare this variable outside of the main method, inside my class block, now this std name can be used in class 1 or in room 1, in room 2, as well as in room 3, as well as many rooms as they are in. So this class variable's visibility is in fact throughout your class. So every method can actually have this. So we can do one other way is we can say set name, and then when we want to do this, we can also say std name is equals to name. So now whatever name you pass to me, I can also set this variable's value here. Now this std name has not been declared inside this method. It's not there, but there's no error as well because this std name is coming from class. This is known as a class variable. Means it's accessible through every single method. So I can use this here as well. I can say colon plus std name. Okay, control S. So see, now both these methods are actually using this std name variable, even though they don't have, it's not been declared inside it. Because it's a class variable, I can use it wherever I want. And then for example, I can say get name, I can print, and then I can use something called a return type, and I can say std name maybe. Okay, so as soon as I write a return, it gives me an error. Hey, this is a void method. Means in declaration, because this is declaration, it's like setting the rules, and you in the rules you have said this will not take any return type. So I can say okay, let's change that. So now what we have done, we have changed a little bit of code. We have done that this method declaration now behaves like a string. This means that when this method gets called at this point, this guy will return a value. This will return a reply to me. So in other words, I'm asking it a question, get me this name. So when I ask him a question, there is a reply. There's always an answer. And I need to receive that answer. Okay. So that's how the question answer goes. When I ask you a question, you reply, and I need to be there to listen to that answer. Good parenting. So that's good parenting needs to be done here as well. So because in my declaration, I've said that this method will take as a string as a return type. So I need to write the code to return the actual value as well. And to return a value, to give a reply, to give an answer, we use a keyword called return, and then we pass it a value. So whatever value we set here will again be used here. Wonderful. See, so this is how a typically logic of the code goes. We declare a variable as a class variable. We use set name to set the value of that variable. We use get name to get the value of that variable. So in this case, I can just comment this value out. Okay, and then I can say, let me just comment this value out as well. So now I'm not printing anything. Okay, so I'm using one method to set the value of the name that's been passed by the argument, and then I'm using one value called get name to fetch me the value. So now when I execute this method, in fact, if I use the same logic, this is error, because get name, if I execute first, will return me null value because there's nothing inside here. By default, that has been declared as null. So what we're going to do now is we're going to change this code. So we're going to say, hey, this line of code, you come after this. So we're going to say std, set the name Dr. Zeeshan. So we set the name first. So when we call this value, it's going to go and set this name. This variable value is passed, and it's going to set this variable's value. So now std name has a name that I used right now. Then I'm going to say, get me that name that I just set. So it's going to return that name for me. Now two things I can do. I can say string n is equals to here, and then I'm going to use system.out.println. Okay, and then I'm going to just print the name here. The new name is colon, and then I'm going to use plus sign, and let me just use enter. So now what we have done, again, this is one way of working with programming, so don't worry about that. The previous example was also correct. We're just changing the code and see what other things we can do. So now what we have done is we have used std1, again using the object, and we asked it to get me this name. So I've called this method. So when I go into this method is going to say, hey, get name. Okay, I'm going to return a name in a string format, and that name is going to be std name variable. So it's going to return whatever is the value inside this variable will be returned as a string, and this string will be again passed on to this variable here. Because this get name will return something, give me a reply, give me an answer, I need to be able to receive that answer. So this is receiving the answer. Once I receive it, now I can process this answer whatever way I want. And this is exactly what we have done in previous examples, where we have used methods such as operators, string methods, math class. We have used these examples multiple times. So here you see we have used math class dot max, and we passed it an argument, and when we execute this method, they return a value. This is exactly what's happening here. So now we're returning it a value, and once we return a value, we need to receive that value. Once we have that value, we can process it whatever we want. Similarly, we create another student object, same way. This time I'm going to say set name this guy, and then I'm going to use system dot out dot println, and I'm going to say hello new guy, and then I'm going to use std2 dot get name. Okay, so now what we have done, let's check this out. And then obviously we miss out the plus. See this is a string, this is a function, so this is going to return a value. In order to make sure they are joined together, we need to use this plus operator. Now in this example, again here what we did, we received a value and we saved it inside a string variable. But what I'm doing now is I'm just directly printing that variable value inside my system.out.println. Another way of doing coding. Okay, so just to see the same example can be done this way, this example can be done this way. Because you have to understand, whenever we call this get name method, it is going to return a string to us, and we need to receive it. We can receive it in a variable, or we can receive it inside another method as an argument, as a function as well. So now Control S, execute it. Let's see if everything is okay. The new name is Dr. Zeeshan. So in this case, the new name, this statement got printed. Now, even though this is variable 1, it uses set name. This set name changes std name. Then we create student 2. We use set name John Paul. Again, this is going to call the same method and is going to use this variable. So same variable is being used, same methods are being used, but we're still getting two different values. How is that happening? Again, the same concept. Every object will have independent copies of its variables and methods. Every object is an instance of a class, meaning that they have an independent individual copies of their methods and their data types. So that's why we declare a class variable. Once you declare a class variable, every object you create will also have a copy of this variable. They can use it independent of what other object is doing. So if other object is doing changing name to John and the first one is doing Zeeshan, perfectly fine, because these two are independent objects here. Capish? I hope you explained that. Now, I did talk about something called constructor. Up till this point, we have not discussed it. Let me very quickly discuss the constructor as well. Constructor are basically these things here. When we use a class name, there's a built-in thing inside Java. That's why I said there's a washroom, right? That's what keep in mind. So there are washrooms, and usually they're separate from the rooms. This is how it's going to behave. Every class has a default constructor. Okay, so what's a default constructor? default, default, const, truct, constructor. These are type of methods. Okay, they are declared exactly in the same way as we have declared the method. So get name, bracket start, bracket close, block start, block close. The two major differences are, first, they don't have a return type. Okay, because they always return an object. In other words, if you understand that. Second, they are always the same name as your class name. They are always the same name as your class name. No return type, same name as class name. This is a constructor. This having a return type, different name from class name is known as a method. That's how we identify. So every class by default, if you don't, if even though if we did not declare anything, yet we are still able to use it because it has this default constructor built in. Whenever we create our own custom class, still that same thing, the Java will automatically put this default constructor in. The primary task of constructors are to create the object, and it has some inbuilt code inside it that is included by default by the Java from its main upper super classes. Okay, so this constructor has several code, and you can write your own code here as well. So for example, I can say system dot out dot println, and I can control Z, constructor CALLD called control S. So this basically means that I've written my own code to the constructor, no problem. This constructor gets executed only once for every object. That's the third major difference. You can call this get name, get name, get name as many times as you want for each object. You can call as many times set name, set name, set name for the same object. No problem. Constructor are only executed once. They are only executed once every time an object is created, and that's it. In order to execute the constructor, you need to create an object. For this particular std1 object, the constructor is called, it's executed one time, and then it dies out. That's it. Then you cannot recall it. Okay, if that makes sense. So this is how constructors basically work. Okay, so I hope this explains few things in basics of Java object oriented concepts. Again, there's a whole major concept that we call advanced Java programming, in which we delve into more advanced topics of Java, which basically meaning, again, this is almost same thing that we've already talked, but these advanced topics have a huge things that we need to work about. And for this course, I'm just going to wrap it up here. I want to see how many people actually get to this particular point and leave your comments for me, so that I know that you have understood, and then I will try to make as part 2 of it if you are interested. If nobody is interested in learning the advanced Java, it's no point for me, so it's up to you guys. So if you are interested in learning more, do leave me a comment, do like and subscribe this channel so that you follow along, and I will be working more on Java and other lectures very soon as well. So this concludes our session. So these are the basic programming concept that I wanted to share with you as quickly as possible. I have a detailed 5-hour video of Java that goes into much more detail about these concepts. And let me know if you want to learn more about any particular topic or anything that you don't understand. I will try to make a video out of it. But if you go for all of these topics, is within 1.5 hours, you can find the basics understanding of what exactly it is. I will be sharing a link very soon of various programming tasks. So the more tasks you do, the better you become. That's how you learn programming. Not just watch the video, do all of these programmings yourself. Try to do as much coding as you want. Try to solve as much real world problems as you can. And then only then you can become a professional programmer, by understanding how to logically solve a problem. Okay, and there are many numerous sites that provide you the links. W3Schools website, I use it regularly. I recommend it, very highly official website. For me, I'm also creating a lab tasks manual that you can use for Java to practice tasks. So I will be sharing the link very soon. I'm still working on it by the time I'm recording this video, so I will be doing that. Anyway, so my name is Dr. Zeeshan Bhatti. If you have enjoyed this video up till this point, thank you very much. Don't forget to like and leave your reply, what you understood in this topic, what do you want to learn more. I will try to work more on these lectures as soon as I can. Thank you very much for watching. See you around.